24-volt control circuits in thermostats should read between 24 volts alternating current and 29 volts alternating current for normal operation. Thermostat systems using 24 volts alternating current rely on a step-down transformer to convert household voltage to a safe control voltage, measure across the R and C terminals with a digital multimeter set to the alternating current range, and record the idle voltage with the thermostat disconnected and the system powered. Under call conditions, when heating or cooling is engaged, the voltage will sag slightly. A healthy transformer typically holds within the acceptable range and drops no more than a few volts under load. If the meter shows a steady voltage above 29 volts alternating current, the transformer secondary may be over voltage, which can damage electronic thermostats and control boards. Replace the transformer with one rated for the correct nominal secondary voltage. If readings fall below 24 volts alternating current, inspect for loose or corroded terminal connections, excessive load from added accessories, or a weak transformer winding. Tighten connections, remove non-essential loads for testing, and consider transformer replacement if low voltage persists. When testing, also check for alternating current waveform distortion or significant voltage ripple using an oscilloscope or a true root mean square meter if available, because some inexpensive meters can mask poor waveform quality that still causes erratic thermostat behavior. Finally, always isolate power at the breaker before making wiring changes and verify transformer primary wiring to the correct line voltage to avoid safety risks. 3 common issues are voltage sag under load, open or high resistance wiring, and incorrect transformer sizing. For voltage sag, measure under both idle and call conditions and replace the transformer if the underload voltage drops below 24 volts alternating current. For wiring problems, remove and inspect thermostat and transformer terminations for corrosion or loose screws, then clean and retighten or replace damaged conductors. For incorrect transformer ratings, confirm the transformer secondary amperage meets the total control circuit demand. If adding accessories, calculate total milliampere draw and choose a transformer with at least 20% higher capacity. BigHomeProjects.com connects homeowners with local contractors who specialize in heating, ventilation, and air conditioning control work and can perform accurate voltage testing and transformer replacement. The site also helps contractors generate leads and manage client requests for residential control system projects.